My name is Babatunde Oluwatosin Ademola. I am here to talk on reanalysis and analyze every aspect of Riemann integral. So let's start with partition. Partition, by definition, let A, B be a closed interval on R. A partition of AB is the set P equals to A equals to x0 less than x1 less than x2 less than less than xn equals to b. Now let me explain this now. They have this kind of graph. They have this. They have, yeah, these are starting points. So let's put it as x naught, which is equals to a. Alright, so let's slice this. Now. Slicing this. You can give here x1, x2, x3, like that up to xn equals to b. Now, if you check from here, from our normal graph, where you have something like this 0, 1, 2, 3. You can see 1 is greater than 0, 2 is greater than 1, 3 is greater than 2, and so on. So as the set, that is the partition here, will be A equals to x0, which is less than x1. You can see less than x1, very true. And x1 itself is less than x2, very true. And x2 is less than x3, very true. Like that, up to the point where we have everything less than what? Xn. So partition is about slicing our rough shapes into parts. So I hope you get the definition. Now let's talk about norm of a partition. Now let A, B be a closed interval. Of course, it is a closed interval. Because in mathematics, if you have this kind of bracket, it shows that A and B are inclusive. But if you have this kind of bracket, it shows that A and B are not inclusive. So having this kind of bracket is telling you that it is a closed interval. Now let's have a sub-interval. Under A and B. Let this be a sub-interval. Of A, B. Now, to determine the size, like distance, it is always the initial, final minus initial. So to look for the space, normal, if you want to look for this now, that's when we want to look for the step size. Here, it will be 1 minus what? 0. 1 minus 0. And you can see the step size here is what? 1. That's how you calculate step size, isn't it? But in this case, we are slicing it, so we are not maintaining any step size. So we just say size of each part. That is the size. To calculate the size of the sub-interval xi minus 1 xi will be xi minus xi minus 1. So, and in math, we have, once you see something like this, you know it's talking about forward difference. And the sub-interval, so far it is still like having an interval within the range of a and b. It shows that the sub-interval is between a and b. So far a and b contain the intervals, so we can say they are sub-interval of a and b. Now the norm of the partition P is given by P equals to maximum of So what does this mean? The norm of a partition is telling you that it is the maximum size. The norm is the maximum size. That is, let's have this kind of graph now. You have something like this, and you have a rough graph, and you slice it. You have x0, x1, x2, x3, x4. Now, the norm of this will be the maximum size, the size with the highest length. You can see that will be the norm. So I hope you grab this.